Good morning, my YouTube viewers. Crystal here. I'm just here because I wanted to do another code review. I believe yesterday I did a code review on the random walk for tractor sales, but I've done some more work on the program that I used. And so what I wanted to do is I wanted to do a code review to reflect the changes that I did to the program. So what we're going to do is we're going to go ahead and do another code review, but it's got some slight changes to it. And I'm doing this because I'm doing a YouTube video review, and I'm going to include the code review in the YouTube video review. So the first thing I did was I imported the libraries. I imported NumPy as MP, which is a numerical library that enables you to perform numerical calculations. I imported Pandas as PD, which is a data processing library that enables you to create and manipulate data frames. I imported Matplotlib, which is a graphics library, and it allows you to plot your graphics on data points onto a graph. I imported Seaborn, which is a higher level graphics library used for statistics. And I imported math that enables you to do more complex mathematical functions that are found in the regular Python library. After I imported, the regular Python program. After I imported the libraries, what I did was I loaded the file, and I got this file from a GitHub account. I have a GitHub account, but I don't really use it that much anymore because where I do my business every day, that account is banned, so I can't get into it. So as a result of that, it sort of has fallen into disuse. But I do have an account, and if I need to use it, I can. But I got this CSV file from another account. So data equals pd.read CSV, and then the web address of the tractor sales. So we use Pandas to actually read the CSV file. And then I check my data.columns equals month, year, and tractor sold data. So you can see that my columns are month, year, and tractor sold. So we checked the info on the data frame, and you can see that the first data frame is an object, and the second data frame, the first column is an object, and the second column is an integer. So what we have to do is we have to, at some point, what we're going to do is we're going to change month, year to a date, because it needs to be converted to a date before we can plot graphs and make forecasts and things like that. And then so one of the things we're going to do is we're going to create a variable called dates, and we're going to use pd.dateRange with a start date of 230101 and a frequency of ms, and periods are going to be the length of data. And then you can see the dates. So we've got dates, all these dates here. So next thing we're going to do is we're going to use the dates to plot a graph. And so we'll plot a graph with the time series. You can see that there's no missing values. Number one, there's a trend, and the trend is that the time series is increasing, and there's also seasonality. So the trend is the long term, and the seasonality is the short term. So that's one thing that you can see from this time series just by looking at it. So we're going to set up a time series. We're going to set up the train and the test sets. So test size equals 120. Really, it should be train size. But features equals month, year, tractor sold. X train equals data features to test size. X test equals data features test size to the colon. And then what we do is we insert code to actually display the graph with the training set and the test set. So you can see that right now. The test set is in yellow because that's what we're going to be doing. We're going to be training for 10 years and testing for 2 years. Well, I'll leave it at test size because if I changed it to train size, I've got to go through and change everything else. So we'll just leave it to test size. So now we're going to do the random forest walk, and this is a little bit different from what we had yesterday, and the reason why is because I made some changes to it. So it's a good thing that I'm doing another code review. So we're going to define the random walk 1D, so this is a one-dimensional random walk. A max step equals 100, x equals 0, y equals xtest.tractor_sol.ilog0. So it's going to be position, the first position. X position equals 0, y position equals y. For I in range 0, n, and n is going to be the length of x test. Step equals np.random.uniform neg1 to 1. So that means it's going to generate a number from -1 to 1. Y equals y plus step times max step. So it's going to be the step times 100. And x equals x plus 1. So x position dot append x, y position dot append y, and it's going to return the x position and the y position. So then we're going to call the formula or function is random walk equals random walk 1D len x test. So it's creating an object for the random walk class and passing a value of n, and n is the length of x test. So now we're going to plot it so you can see that our forecast is plotted. So y hat equals random walk 1. So because random walk has 2 values to it, it has a 0, which is the time, and 1, which is the actual value. So what we wanted was 1. So we've got y hat here. There's 25 values there, but we only want 24 values, and we want to take off the first value because the first value is actually not a prediction. It's the first value is the first value of your x test, so we don't want that. So remove the first value, and so this is your first. So when we remove our first value, we've got 24 elements to the list, and that's what we want, 24 elements. And we're going to calculate our errors. Let's see what we've got here. We're going to calculate our errors. We're going to do mean squared error and root mean squared error. And so RMSE is 237.59 in this instance. Then what we're going to do is we're going to difference it. And what differencing can be used to take out the trend and the seasonality. But so we just got differencing. So first order diff equals NP diff y hat. Second order diff equals NP diff y hat n equals 2. Third order diff equals NP diff y hat n equals 3. And then what you can do is we printed all this out. So we printed our input array, and then so your the first order diff is the difference between the input and the forecast, and the second order diff is the difference between Anyway, it doesn't matter. We've got our first order diff, our second order diff, and our third order diff. But the first order diff is the difference between the true value and the forecast. And so they give you a 75 is your difference, and then it goes on that way. And then I just kept the second order diff and the third order diff in there just because I actually got the formula off of Geeks for Geeks, and then Geeks for Geeks gave you the formula, so I decided to leave it in just in case anybody wants a second order diff and a third order diff, but we didn't really need it even though I put it in there. And now what we're going to do is we're going to do a Dicky Fuller test. And what your Dicky Fuller test does is it checks for stationarity, I believe. Let me just look and see. The augmented Dicky Fuller test is used to test for stationarity, so I was right. It does test for stationarity. So, let's just bring it up again. It's been really slow today. So, it tests for stationarity, and it also checks your p-value. It says that if the p-value is less than 0.05, then reject the null hypothesis and conclude that the series is stationary. So our p-value is higher than that, so it's not stationary. And then now after we've done that, we check for autocorrelation. So here's your autocorrelation function, and I'll check here. Autocorrelation measures the correlation of a time series with itself at past lag times. It measures the self-similarity of a signal over different delay times. Past values and lag values mean the same thing. A lag 0, there's autocorrelation of 1. So that's your autocorrelation. And obviously, I'm still learning time series, so I'm not an expert at it, which is why we're doing the code review, because if I was an expert, I would be, having a job doing this, making lots of money, So we've done our autocorrelation. So now what we wanted to do is we wanted to compare the true values and the predicted values, so you can see that there's a comparison between the true and the predicted values here with the data frame. And then so we change our dates. We had to change our dates around, so data month equals data month year, and then we're only using the first 3 characters of the string. Data year equals data month year, and we're using the 4th and the last characters of the string. So data drop month year axis equals 1, in place equals true. So that means you don't need the month year anymore. And then we're going to create a new data month year. Data month year equals data month plus 20 plus data year. So now we put a 20 in there to let you know that these tests were done in the 21st century. Data month year equals PD to date time data month year. So we converted it to a date. Data TS equals data. Data TS timestamp equals PD to date time data month year format. And then it gives you the format. Data TS.index equals data TS timestamp. Data TS drop month axis equals 1, in place equals true. And then we're going to convert it to a daily mean. So data TS equals data TS resample M mean, and then your data TS. And so this is converted to a mean. So this is your sample sold, your predicted sample sold. So now we're going to do some more slicing. Xtrain equals data ts.loc 2003 0101 to 2012 1231. Xvalid equals data ts.loc 2013-0101 to 2014-1231. And then so we create, so y hat equals PD data frame y hat. So now we're creating a data frame of y hat. Y hat dot index equals x valid index. So y hat's index is going to be the same as x valid's, and then y hat. So now we change the index to dates, and now we're going to plot it. And so we plotted it on a graph, and you can see the plot on a graph. But this is a random walk, so every time you rerun the random walk, you're going to get a different figure. And I had been getting like negative random walks, so I've been getting figures down here. So I had to rerun the random walk several times just so I can get a value that was like close to what the true values were. So that's it. That's it for this code review. It's a code review that we did yesterday, but I added some things to it. And please keep in mind that I'm still learning time series, and as a result of that, I'm not 100% proficient on a lot of these functions and things. If I was 100% proficient on all of this, then I could go to a company and get a really good job doing time series and hopefully working from home because of my age and my health. I don't want to travel so much. So maybe at some point I'll get a job working from home on my computer at home, and then I'll get more money. Who knows? So thank you so much, all of my subscribers to my channel. Thank you so much for subscribing to my channel. If you like my video, please like, subscribe, and share. Thank you for watching my video, and I look forward to making more videos for you in the future.